Morning students, in the previous class we have learned about the integration by parts. This integration by parts is specially useful when the integral contains the product of two functions, and in the exceptional cases when the integrand contains only one function, like integral root of a square minus x square dx, root of a square plus x square dx, integral root of x square minus a square dx, and the inverse trigonometric functions like integral sine inverse x dx, integral secant inverse x dx, integral tan inverse x dx, etc. And the logarithmic functions like integral log of 1 plus x dx, log x square dx, etc. And exponential functions where the second function is treated to be the unity. So, and further the order of f of x is depending on the phrase islet, where I refers to inverse, L refers to logarithmic functions, T refers to trigonometric functions, A refers to algebraic functions, and E refers to the exponential functions. This is what we have discussed before. So now we know that d by dx of e power x into f of x is equals to d by dx of u into v, product of two functions. So d by dx of uv is uv dash plus vu dash, that we know. So e power x into d by dx of f of x plus f of x into d by dx of e power x. So this is e power x into d by dx of f of x is f dash x plus f of x into d by dx of e power x is itself. Now if you take e power x as a common, then we will get f of x plus f dash x. So this is equals to d by dx of e power x into f of x. Now integrating on both sides we will get this. Whenever we are integrating, along with this integral symbol, dx is to be followed. So integral dx. So integrating on both sides. So integral and derivative are the reversal processes. Therefore, we'll get e power x into f of x plus c. If you integrate, the constant of integration is what we will get. So integral of e power x into f of x plus f dash x whole dx is equals to this we will get. Therefore, this can be used as a formula also. Integral e power x into f of x plus f dash x dx is equals to e power x into f of x plus constant of integration c. For example, integral e power x into secant square x plus tan x dx. So if you are asked to evaluate the integral of this, then simply first we need to check which is the original function. Tan x is the original function or secant square x is the original function. So ask yourself, d by dx of secant square x is tan x? No. But d by dx of tan x is secant square x. Therefore this is f of x and its derivative is this is f dash x. Now it is on the form e power x into integral e power x into f of x plus f dash x dx. The formula is e power x into f of x plus c. So e power x into, what is f of x in this two? This. So e power x into tan x plus c. So in this way we will find the integral of this. Now let us work out some problems from the exercise 6c. Evaluate the following integrals. Integrals x secant square x dx on I is subset of R such that 2n plus 1 into pi by 2 where n is an integer. So here you can clearly see that this integral contains the product of two functions. X, which is the algebraic function, and secant square, which is the trigonometric function. So compare with islet. So in islet, A comes first and then T. So x is to be treated as f of x. So f of x is equals to x and g of x is equals to secant square x. So we have the formula integral of f of x into g of x dx is equals to f of x into integral g of x dx minus integral of d by dx of f of x into integral g of x dx whole dx. So this formula we have derived also. Now, so this is x secant square x dx is equals to f of x is x integral secant square x dx. All that I'm doing here is just to plug in x in the place of f of x and secant square x in the place of g of x. Just I'm substituting here. Integral d by dx of x into integral secant square x dx whole dx. X into integral secant square x dx is tan x minus d by dx of x is 1 into integral secant square x dx is tan x. Integral secant square x dx is tan x. This dx is this. So this is x tan x minus 1 into tan x is tan x. Integral tan x dx is log modulus of secant x plus constant of integration c. Integral e power x into tan inverse x plus 1 by 1 plus x square dx. So this is our form integral e power x into f of x plus f dash x dx. This is what we have discussed in this video itself, in the starting of this video. So here tan inverse x is f of x and tan inverse x derivative is f dash x. So we have integral e power x into f of x plus f dash x dx is equals to e power x into f of x plus c. So therefore integral e power x into tan inverse x plus 1 by 1 plus x square dx is equals to e power x into, here f of x is tan inverse x. So e power x into tan inverse x plus constant of integration c. Log x by x square dx on 0 to infinity. So here integral log x, this is into 1 by x square. Into 1 by x square can be written as x power minus 2 dx. So this is algebraic. This is logarithmic. In ILAT, L comes first and then A. So here f of x is equals to log x and g of x is equals to x power minus 2. We have integral f of x into g of x dx is equals to first function into integral of second function dx minus integral of differential quotient or derivative of first function into integral of second function dx whole dx. So this is equals to log x by x square dx is equals to f of x is log x into g of x is x power minus 2 dx minus d by dx of f of x is log x into g of x is x power minus 2 dx whole dx. So this is equals to log x. Integral 1 by x square is minus 1 by x. This x power minus 2 in the sense 1 by x square dx minus d by dx of log x into x power minus 2 is 1 by x square dx whole dx. This is equals to log x into integral 1 by x square is minus 1 by x minus d by dx of log x is 1 by x into integral 1 by x square is minus 1 by x whole dx. Integral 1 by x square dx is minus 1 by x bracket closed dx. This is minus 1 by x into log x. So minus into minus plus. This is 1 by x square can be written as x power minus 2 dx. Minus 1 by x log x plus x power minus 2. Integral x power n dx is x power n plus 1 by n plus 1. So x power minus 2 plus 1 by minus 2 plus 1. So this is x power minus 1 by minus 1. So this is minus 1 by x. So integral 1 by x square dx is minus 1 by x plus constant of integration c. So this is equals to minus 1 by x. If you take common, this is 1 plus log x plus constant of integration c. Now fourth question is integral log x whole square dx on 0 to infinity. So this is equals to log x whole square. So integration by parts is also useful when the integrand contains only one function, like logarithmic, algebra, inverse trigonometric functions, integral root of a square minus x square, etc. There, the second function is treated to be 1 dx. So obviously this is f of x and 1 is g of x. So f of x is log x whole square and g of x is equals to 1. So this is equals to log x whole square dx is equals to f of x is log x whole square into g of x is 1 dx minus integral of d by dx of log x whole square integral g of x is 1 dx whole dx. Log x whole square integral 1 dx is x minus d by dx of log x whole square. That we don't know. But if you treat this to be x, then we know d by dx of x square is 2x. So 2 into x value is log x into, since log x we have treated to be x, we need to differentiate that thing which we have taken as x into d by dx of log x, which is 1 by x. Integral 1 dx is x whole dx. So x gets cancelled. This is x log x whole square minus 2, separate it from the process of integration, integral log x dx. So this is equals to x log x whole square. So we have seen integral log x dx yesterday. That is x log x minus x. So we have taken this particular one as an example and we have derived it also as the previous class. But if you want, I will do it for you. 2 into. So integration by parts is also applicable for the logarithmic functions where the second function is treated to be 1. So first function into integral of second function, because log x into 1 we can write that into 1 minus integral of d by dx of first function into integral second function dx whole dx. So 2 is multiplying with the whole. So this is equals to x log x whole square minus 2 into log x integral 1 dx is x minus d by dx of log x is 1 by x. Integral 1 dx is x. This is dx. Integral 1 dx is x bracket close dx bracket off. So this is equals to x log x whole square minus 2 x log x. So x gets cancelled. Integral 1 dx is x. So this is minus x minus of minus plus 2x plus constant of integration c, because this is x gets cancelled. Integral 1 dx. Integral 1 dx is x. So minus x is this. Minus into minus plus 2 into x, 2x plus constant of integration c. Integral e power x into secant x plus secant x tan x dx on I is subset of R, where 2n plus 1 into pi by 2 n belongs to z. So this is the form e power x into f of x plus f dash x dx. And we need to check which is f of x and which is f dash x. So we know that d by dx of secant x is secant x tan x. Therefore, this is f of x and this is f dash x. So integral e power x into f of x plus f dash x dx is equals to e power x into f of x plus c. So therefore, e power x into f of x here is secant x plus constant of integration c. The next question is e power x into cos x dx on R. So here I'll take it as let I is equals to. So this is equals to e power x is exponential function, cos x is trigonometric function. So in I let, so t comes first and then e. So cos x is f of x. F of x equals to cos x. And g of x is e power x. So this is equals to, first function is cos x into integral of second function dx minus integral of d by dx of first function into integral second function dx whole dx. This is the formula that we have learned before. Integral f of x into g of x dx is equals to f of x into integral of g of x dx minus integral of d by dx of f of x into integral of g of x dx whole dx. This is equals to cos x cos x into integral e power x dx is e power x minus, actually e power x dx is e power x plus c, but that plus c, the constant of integration will be added at the end of the problem, so no need to add plus c here, minus integral of d by dx of cos x is minus sin x into integral e power x dx is e power x. Integral e power x dx is e power x bracket close dx. This is e power x into cos x minus into minus plus integral e power x into sin x dx. So again we got the product of two functions. So whatever the process that we have done so far, the same process is to be continued again because the product of two functions. So this is equals to e power x into cos x plus, here the first function is sin x. So first function into integral of second function dx minus integral of d by dx of first function into integral of second function dx whole dx. So this is equals to e power x into cos x plus sin x integral e power x dx is e power x minus d by dx of sin x is cos x into integral e power x dx is e power x dx. Integral d by dx of sin x is cos x. Integral e power x dx is e power x. This dx is this. So this is equals to e power x into cos x plus, this is e power x sin x minus this integral cos x into e power x dx. is I is what we have taken before. This is I. This is all I. This minus I on transposing on to another sign, this will be plus I. So I plus I is 2I is equals to take e power x as common in both of them. Then we'll get sin x plus cos x. Therefore, I is equals to e power x. This 2, it is multiplying, it would be dividing into sin x plus cos x plus constant of integration c. So this is how we have to evaluate this integral e power x into cos x dx. Integral e power x into sin x plus cos x dx on R. So here sin x derivative is cos x, but not cos x derivative is minus sin x. So here, if you take it as f of x, then it will be f dash x. So we have integral e power x into f of x plus f dash x whole dx is equals to e power x into f of x plus constant of integration c. Therefore, e power x into sin x plus cos to f of x here is sin x. So sin x plus constant of integration c. So integral tan x is equals to log mod secant x of e power x dx. So this is equals to e power x into tan x plus log secant x only. Now we know that tan x derivative is secant square x. d by dx of tan x is secant square x. Therefore, it won't be f of x because its f dash x is not this. So we have to think on the other way around. So let us take it as f of x. Let us see what will happen. Let f of x is equals to log secant x. Then f dash x is now differentiate. Secant x you take it as x. So now it has become log x. What is d by dx of log x? Why d by dx of f dash x is what I am doing. That means differentiating. So if you treat it as x, then log x derivative is 1 by x. So 1 by secant x into, since secant x is treated to be x, so we need to differentiate it. So d by dx of secant x is secant x into tan x. Now secant x gets cancelled. Therefore, f dash x is equals to tan x. Therefore, integral e power x into tan x plus log modulus of secant x dx is equals to e power x into f of x according to the formula. So e power x into f of x here is log secant x. So this is log secant x plus constant of integration c. Integral x power n into log x dx on 0 to infinity, where n is a real number with n not equals to minus 1. So here obviously x power n into log x product of two functions. This integral contains the product of two functions. Therefore, the method of by parts is applicable here. So x power n, x power something is treated as an algebraic function and log x is logarithmic function. So in I let f of x is equals to log x. In I let L comes first and then A. So g of x is equals to x power n. We have integral f of x into g of x dx is equals to f of x into integral of g of x dx minus integral of d by dx of f of x into integral of g of x dx whole dx. So this implies x power n into log x dx is equals to, first function here is log x into integral x power n dx minus integral of d by dx of log x into integral x power n dx whole dx. So this is equals to log x integral x power n dx is x power n plus 1 by n plus 1 minus d by dx of log x is 1 by x into integral x power n dx is x power n plus 1 by n plus 1 dx. So this is 1 by n plus 1 into x power n plus 1 into log x minus 1 by n plus 1. Separate this from the process of integration. Integral x power n plus 1 by x. So this is x power n plus 1 minus 1. Therefore this is x power n dx. So 1 by n plus 1 into x power n plus 1 log x minus 1 by n plus 1. Integral x power n dx is x power n plus 1 by n plus 1 plus constant of integration c. So this is equals to 1 by n plus 1 into this is x power n plus 1 into log x minus 1 by n plus 1 is taken common here. Therefore this is x power n plus 1 by n plus 1 plus constant of integration c. So here we can even take x power n plus 1 common in both of them. Therefore x power n plus 1 by n plus 1 into log x minus 1 by n plus 1 plus constant of integration c. And if you take n plus 1 LCM here, then we will get x power n plus 1 by n plus 1 into n plus 1 is n plus 1 whole square. So if you take n plus 1 as LCM, then n plus 1 log x minus 1 plus constant of integration c. Integral of log 1 plus x square dx on R. So the second function here is treated as 1. So this is integral of log 1 plus x square into 1 dx. So this is f of x and this is g of x. So this is equals to f of x, first function log 1 plus x square into 1 dx minus integral of d by dx of f of x is log 1 plus x square into integral 1 dx whole dx. Log 1 plus x square integral 1 dx is x minus d by dx of log 1 plus x square. Let us suppose this to be x because we only know d by dx of log x, for which this unknown you treat it as x. So d by dx of log x is 1 by x. So 1 by here x is 1 plus x square into d by dx of whichever that we have treated it to be x, later we need to differentiate into d by dx of 1 plus x square integral 1 dx is x whole dx. This is equals to x log 1 plus x square minus integral 1 by 1 plus x square d by dx of 1 by 1 plus x square is 1 derivative is 0, x square derivative is 2x into x. So 2x square dx. Integral 1 dx is x. D by dx of 1 plus x square is x square derivative is 2x. This is 2x into x, 2x square. So this is x log 1 plus x square minus 2 I am separating from the process of integration. This is x square by 1 plus x square dx. 2 I have written here. This is x square by 1 plus x square. So here I will add with 1 and subtract with 1. Then we will get x log 1 plus x square minus 2 into 1 plus x square by 1 plus x square is 1. So integral of this is 1 minus this is 1 by 1 plus x square whole dx. A minus b by c. A by c. 1 plus x square by 1 plus x square is 1 minus 1 by 1 plus x square. So integral of dx 2 is multiplying with as a whole. So this is equals to x log 1 plus x square minus 2 into this is integral 1 dx minus integral of 1 by 1 plus x square dx. So this integral is distributed for these two integrals, for these two functions. So x log 1 plus x square minus 2 integral 1 dx is x minus integral 1 by 1 plus x square dx is tan inverse x plus constant of integration c. This is equals to x log 1 plus x square minus 2x minus into minus plus 2 tan inverse x plus constant of integration c. Integral root x log x dx on 0 to infinity. So here the log x is logarithmic function, root x is algebraic function. In islet, L comes first and then A. So here this is equals to f of x into integral g of x dx minus integral of d by dx of f of x into integral g of x dx whole dx. So this is equals to log x integral root x is x power 1 by 2. Integral x power n dx is x power n plus 1 by n plus 1. So x power 1 by 2 plus 1 by 1 by 2 plus 1. X power 3 by x power 3 by 2 by 3 by 2. So 2 by 3 x power 3 by 2 minus d by dx of log x is 1 by x. Integral root x is 2 by 3 x power 3 by 2 dx. So this is equals to 2 by 3 x power 3 by 2 log x minus 2 by 3 into this is x power 3 by 2 by x. So x power 3 by 2 minus 1. This is x power 3 by 2 minus 1 by x power 3 by 2 minus 1. So this is 3 minus 2 by 2. So x power 1 by 2 as a whole. So this is root x dx. This is x power 3 by 2 minus 1. So x power 3 minus 2 by 2. So 3 minus 1. So x power 1 by 2. This is integral root x dx. So this is equals to 2 by 3 x power 3 by 2 log x minus 2 by 3 integral root x dx is 2 by 3 x power 3 by 2. X power 3 by 2 So this is equals to 2 by 3 x power 3 by 2 log x minus 4 by 9 x power 3 by 2 plus constant of integration c. Integral of e power root x dx on 0 to infinity. So we can proceed with integral e power root x into 1 because this is a special function. When the integral contains the exponential function, the second function is treated to be unity. So here e power root x into 1 and we can proceed taking e power root x to be f of x and then g of x is 1. Instead of that, let whatever that is under root, let us take it as t square. That's what we have learned right from the beginning. So let x is equals to t square. Now differentiate. Dx is equals to 2t dt. Now this is equals to e power x is t square, root x is root t square, which is t, into dx is 2t dt. So 2 I am writing outside of the integration, t dt. So 2 into, so here e power t is like e power x, t is x, because we have changed the variable. Therefore this is, instead of e power x into x, it has become e power t into t. So here isolate a product of two functions. This is algebraic and this is exponential. So first function is isolate. A comes first and then e. So first function into integral second function dx minus integral of d by dx of, not d by dx of, d by dt of, because change of variable is happened here. First function into integral of second function dt whole dt. And this 2 is multiplying with the whole of e power t into t dt. Therefore, this is the closed bracket. 2 into t, integral e power x dx is e power x, integral e power t dt is e power t, minus d by dt of t is 1 into integral e power t dt is e power t whole dt is this. So 2 into t e power t minus 1 into e power t is e power t. So integral e power t dt is e power t plus constant of integration c. So 2 into, take e power t common in both of them, then this is t minus 1 plus c. So 2 into e power t value is x is t square while root x is equals to t. So e power root x into root x minus 1 plus constant of integration c. Integral of x square cos x dx on R. So here x square is algebraic function, cos x is trigonometric function. In isolate, so a comes first. So f of x here is x square while g of x is equals to cos x. So now integral x square cos x dx is equals to f of x into integral of g of x dx is equals to f of x, which is x square, into integral of g of x is cos x dx minus integral of d by dx of f of x is x square into integral of g of x dx is cos x dx whole dx. This is equals to x square integral cos x dx is sin x minus d by dx of x square is 2x. Integral cos x dx is sin x whole dx. So this is equals to x square sin x minus 2 into x sin x dx. Again, product of two functions arised. Therefore, again we need to apply by parts. So x square sin x minus 2 into, so the first function is x here, first function into integral of second function dx minus integral of d by dx of first function into integral of second function dx whole dx. So this is equals to x square sin x minus 2 into x, integral sin x dx is minus cos x. d by dx of x is 1 into integral sin x dx is minus cos x. Integral sin x dx is minus cos x. This dx is this. I'm closing the set bracket. So x square sin x minus into minus plus 2x cos x minus into minus plus into minus minus 2 into sin x is this. Because integral cos x is sin x, this 2 is multiplying here. Integral of x sin square x dx on R. So this is equals to first function, this is algebraic and this is trigonometric. Therefore, first function is f of x and this is g of x. But sin square x we cannot take and proceed because had it been sin 2x plus 3, sin 4x etc., sin associated with the linear factors we can differentiate, we can take. But sin square x, sin cube x, sin power 4x, it will be complicated. Therefore, first we will rewrite it as x. Sin square x can be written as 1 minus cos 2x by 2 dx. This is what we have learnt in trigonometry. So, cos 2x has got 4 formulae: cos square x minus sin square x, 2 cos square x minus 1, 1 minus 2 sin square x, or 1 minus tan square x by 1 plus tan square x. So, cos 2x is equals to, one of the formula is 1 minus 2 sin square x. So 2 sin square x is equals to 1 minus cos 2x. So this 2 is multiplying, it will be dividing. So sin square x can be written as 1 minus cos 2x by 2. So this is equals to 1 by 2. I am separating it from the process of integration. This is x minus x cos 2x dx. So this is equals to 1 by 2. This is integral x dx. This integral dx I am distributing for these two functions. So integral x dx minus integral of x cos 2x dx. So this is equals to 1 by 2. Integral x dx is x square by 2 minus. Now the product of two functions came. So here this is algebraic function and this is trigonometric function. So first function into integral of second function dx minus integral of d by dx of first function into integral of second function dx whole dx. So bracket closed. And this bracket is this. 1 by 2 x square by 2 minus x. Integral cos 2x is, let us suppose this to be x, then it has become integral cos x. Integral cos x is sin x. So this is sin 2x by its quotient we need to divide by 2. Minus d by dx of x is 1. Integral cos 2x is sin 2x by 2. Integral cos 2x, this cos 2x dx whole dx. Now, integral cos 2x dx is sin 2x. This dx is this. Bracket closed, this. So 1 by 2 into x square by 2 minus, this is x by 2 sin 2x minus into minus plus 1 by 2. Integral sin 2x is minus cos 2x by 2. Minus into minus plus this 1 by 2 I have written separately. Integral sin 2x dx is minus cos 2x by 2. This. So therefore 1 by 2 is being multiplied with the whole thing. Therefore x square by 4 minus x by 2 to the 4 sin 2x So plus into minus minus. 2 2s are 4, 4 2s are 8. So 1 by 8 cos 2x plus constant of integration C. Similarly, seventh question, we can make alternation here, x cos square x dx. So cos square x is 1 plus cos 2x by 2. So this will be plus. This is plus, 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 plus. This is plus. So this is plus. So integral x dx, integral x cos 2x dx. So first function into integral of second function dx minus integral of d by dx of first function into integral of second function dx. So integral cos 2x is sin 2x by 2. So integral x dx is plus x cos 2x dx. Integral x dx is x square by 2 plus first function into integral of second function dx minus integral of d by dx of first function into integral of second function dx whole dx, this. So this is x square by 2, x integral cos 2x is sin 2x by 2 minus d by dx of x is 1, integral cos 2x dx is sin 2x by 2, this dx is this. So 1 by 2 x square by 2, this is x by 2 sin 2x. Integral sin 2x is, here 1 by 2 I have written here, integral sin 2x is minus cos. So this is minus of this minus, so this will be plus in case of integral x cos square x dx. So if you do not understand, pause the video and see how we have solved for integral x sin square x dx. Then you will realize what has happened here. Thank you.